What's up everybody, welcome back. So we've been doing some work on our framework and UI for quite a while now, and I think we have a pretty solid base standing with most of the really required features in there. So let's switch things up a little bit and start doing some work on our character. In the first episode we created a pretty simple animation blueprint in something like half an hour or something, and we're gonna continue to improve on that. In this episode I want to start looking at turn in place animations, and this is how it's going to work. So the upper body is going to rotate till a certain offset, and then the lower body will align itself again. And if we start moving, the upper and lower body will align itself, and then we can just aim like we would normally. So this is based on the Lyra starter game animation setup, although ours is going to be far less advanced. So this is really more a beginner level to get you started and to improve your projects from here on. So let's just dive into it and start setting this up. So first of all, because we created this entire framework with the menus and things, we need to fix some stuff to be able to test in Pi. So if I'm going to launch the game in the editor right now, I won't be able to test it without going through the menus. And I want to fix that, because if we're going to test animations and things like that, that's going to take up a whole lot of time. So this is what happens when we spawn in right now. And to fix that, we need to go into our shooter game mode. And because we don't walk through all the menus, the variables in here are not set. So the number of expected players in the solo game. So what I'm going to do is go to the branch over here in the event handle starting new player. And in the branch where we check the number of expected players, I'm going to add a little print that says the play in editor launch is enabled. So I know I connected this pin up here, and then I'm going to simply connect it to the for each loop. So this will make sure that we can spawn into level. And then I'm also going to reduce the 3-second delay to 1-second delay. So that saves me a lot of time as well. So that's in the level start event. After the first for each loop we had a 3-second delay for the countdown, and I'm going to reduce that to 1 second. And then also open up my in-game HUD widget, and in here I'm going to make sure I adjust the delay as well. So we have the game start countdown event, and I'm going to get the visibility node and plug it right into the last 1 second countdown over here. And then it's going to say round 1 and start the game. So right now if we press play, we can just launch in our normal map and we can test our animations. The HUD will not be working, but I don't care about things like that right now, so we got that out of the way. Let's start working with the animation blueprint. Let's open up the animation blueprint that we started in the first episode, and we're gonna clean this up a little bit. So to start with, we have our blend space in the animation graph, and we place the unarmed animations in there. I want to get rid of them and just start the game with a pistol, so we are ready for action whenever the level starts. So I'm going to open up the blend space, and on the left side here I'm going to click the little bin icon, so all of the animations will be moved. And then I'm going to search for the pistol animations. So first I need the pistol walk animations, or let's start with idle by the way. If you're using the female character, you want to use for the MF, search for the MF animations, and if you use the male, you want the MM animations. There are some differences between them, so keep that in mind. So first of all, let's get our pistol idle hipfire, and let's drop it all the way at the bottom, in the center, and all the way to the right and the left. So we have it 3 times in here at the lower row. And then we're going to look for the pistol walk animations and plug them in as well. So start walk backwards, that's going to be all the way to the right and all the way to the left. And then in the center we're going to plug in our walk forward, and in between them the left and the right animations. So left goes on the left side and right on the right side. And after that we're going to look for the jog animations as well and plug them in the same way. So with the backwards it's going to go all the way to the right and all the left. Forward goes in the center again, and then plug in the left and the right animations on the left and the right side. There we go. So we have our blend space changed up, and now we have pistol animations in place. So the next thing I'm going to do is go to my AimOffset over here, and I plugged in the base pose, but I used the male version. So I'm going to get rid of this one and grab the female version. So that's female pistol ADS. And then the idle ADS one, and drop it in here and connect it up. And for the layered blend per bone node, you want to make sure that you enable the mesh space rotation blend. I don't think I mentioned that in the first episode. So you want to select the layered blend per bone and enable this flag over here, and that will make sure your animations look a whole lot better. So that's the stuff that we are going to clean up in here. And now let's dive into our character and start working on the turn in place animations. So to get our turn in place animations working, we're going to use our AimOffset, and in here we have a variable for the yaw, and we're going to use the rotation of the AimOffset to get our turn in place animations working. So first of all, we're going to dive into our character and go to the class defaults over here, and we want to disable the use controller rotation yaw. So deselect that. And if we compile and save right now and we go in game, we cannot rotate the character anymore. So we need to make sure that right now the upper body will align itself with the camera rotation. So that's what we're going to do next. And I'm going to try and do my tutorials a little bit different, where I'm not going to simply lay out the entire graph at once, but I'm going to go through it step by step to try to explain what everything does. So we're probably going to do one subject per video and have a little bit more explanation. So first of all, we're going to use event tick for the local player, and then we're going to replicate that to other players. And we are only going to use tick for the local player. So for other players, I'm going to disable it. So over here we have begin play, and we check if we are a local controlled player. So if this is false, I'm going to simply drag off here and set actor tick enabled to false. Set tick enabled, and this will make sure that the tick function doesn't run on the other instances of my character, so simply to prevent stuff happening from there. So I'm going to grab event tick in here, and first I'm going to check if I'm a locally controlled player or not, so I can just copy and paste that stuff over here. And then we want to get the rotation of our camera, so let's get a little room here, and we're going to grab our base aim offset. So get base aim offset rotation, sorry. And we're also going to get our actor rotation. And then we're going to get the difference between them. So drag off the base aim rotation and get a delta rotator and plug the actor rotation in the D pin. And then we want to split the outcome, so right click on the pin over here, and we're going to grab the Z value, so that's the angle of the camera that we're interested in. So let's right click this and promote it to a variable, and this is going to be my new yaw offset. And I'm going to duplicate the variable, and I'm going to call this the normal yaw offset. And for the yaw offset, you want to keep it selected and make sure that we set it to replicate. So replicate it over here. Now we can plug the setter for the new yaw offset into the true pin over here. And then we want to know if we are the server or not. So we are a local player, but that doesn't say anything about our actual role. So let's grab the has authority node. And if we are the server, we can simply set the yaw offset ourselves, and because we are the server, it will replicate to the other clients. So I'm going to drag the setter in here for the replicated variable, the yaw offset, and then I'm going to set it to the new yaw offset that we just calculated over here. And if we are a client, then I want to call a replicated event. So I'm going to create a custom event over here and call this server set yaw offset. Set yaw offset, and on the right side we're going to set this to replicate to run on the server. So if it's called from the owning client to the server, then the server will execute this event. And we're going to simply set our yaw offset, so drag in the setter, plug it in, and if you drop the variable on the node, then it will create the variable in the event for you. So then over here for the remote, we're going to simply call that function, so server set yaw offset, and over here we're going to plug in the new yaw offset. And to prevent any feeding of lag for the client locally, we're going to grab the setter and paste it over here as well. So the client sets it locally, and this will smooth things out a little bit, especially for controls. That's pretty useful to do. So this is also why I calculated this variable over here, and why I don't just plug it in like this, because then over here we have to calculate it twice if I would plug it in like this. Instead of using a variable, then it will actually calculate the value twice, and if we store it in a variable and just plug it in over here, then it will be a tiny bit more efficient. So this is the setup for the yaw. And if we are going to go to our animation blueprint, then we can grab that yaw and plug it into our aim offset. So let's go to the event graph over here. We have a reference to our character stored. So I'm going to simply drag off the character here and get my yaw offset. And make sure you get the yaw offset and not the new yaw offset. So we want to get the replicated variable. And we're going to simply promote it to a variable over here. And that's my yaw angle. And make sure we set it. So for the animation blueprint exists on every instance of the game. So just like your character, it will exist on a client version of the game as well. So if you make sure that the variables that drive your animation graph, so for example the yaw offset, if that variable is replicated, then your animation graph will match up between all the clients, because it will run on each instance of the game. So as long as the information that it gets is the same, then the animations will match up. So you don't really need to worry about replicating anything inside the animation graph normally. So we have the yaw stored in our event graph. So if we go to the anim graph and plug it into our aim offset over here, then we should have a working aim offset, but this will only work inside ADS right now. But let's just see how this is working. So let's play the game. So as I mentioned, if I'm not ADSing, nothing will happen. And if I ADS right now, then the upper body will rotate with the camera and turn way around. So it overstretches, but we're going to look into that as well. So we have the first part of our setup done. Now let's fix that we don't have an aim offset in the Hipfire. So let's go back into the animation blueprint, and over here we want to make sure that we also grab an aim offset if we are not ADSing. So let's disconnect this over here, and we're going to grab our layered blend per bow node and simply copy it in here and plug this in the same way, just like we did above here. And now there is one small issue with this, because the pistol only has an ADS aim offset. There are no pistol hipfire animations in this project. So all we can do to fix this is simply copy the ADS aim offset, and instead of plugging in the idle ADS animation, we're going to plug in the idle hipfire animation. So this will make the base pose of the aim offset change, and that's why the aim offset itself will still look pretty decent, but as I mentioned, these are actually ADS animations. Oh, come on. As you can see here, so all we do is change the base pose over here, and the animations in here are actually additive. So there will be a little bit offset, and it may not look the cleanest, but at least we have ADS and hipfire. So then we're going to copy and paste the yaw and the pitch over here again. And now we should have an aim offset outside ADS as well. So let's go in game. And as you can see, the body now also rotates if I'm not ADSing. So we have that set up as well. Now let's see how we can make the lower body move as well. So let's have a look at the animations that we're going to use for the turn in place. So if we go to the animation folder, go to locomotion, pistol, and then if you search for turn, then we're going to grab all the turn animations in here. So we're going to use the root motion that's in the animations, and that will simply mean that the turning of the character that inside the animation over here will drive the actual motion of the character in game. So if you look on the left side over here, we have settings for root motion, and you need to make sure that root motion is enabled if you want to make sure this actually works. So we're going to use the turn left, right, turn right, the turn left 90, the turn right 90, and the turn right 180 animations. And the main reason for not using the left 180 is because for some reason the root motion in that animation sequence doesn't seem to work. And although we are going to use the 180 animation, that's only if we really over rotate the camera and we are facing the character, then it's going to jump 180 to make sure he's aligning faster. So it's not going to be something we are using a lot in game. And it also really doesn't matter because we are 180 degrees on the other side. So if the character turns left or right, he ends up in the same direction anyway. So let's have a look at one of these animations, and if you drag the timeline, you're going to see the last part of the animation, the character is pretty much just standing still. And because our animation graph is going to be a whole lot less complicated, I just want to simply get rid of the frozen frames at the end. So if you want to, you can make backups of the animations, and then I'm going to simply drag the timeline over here to frame 25 for the turn 90 animations, and then I'm going to right click and remove frame 26 to 15. So we have a 26 frame animation over here, and then save it, and I'm going to do the same for the turn right 90 animation, so that's this one, and also, oh come on. Put the timeline at frame 25 again and remove the rest of the frames. And for the 180 animation, so that's turn right 180, I'm also gonna remove the frames, but this time I'm gonna remove them from frame 36. So it's a little bit longer, but still all of the movement is in here. So we can close these down, and again make sure you grab the MF versions for the female and the MM versions for the male character, depending on which one you're using. Now I don't want to remove the filter because right now we want to create montages of these animations, and if we are using montages we can actually use root motion. So just right click on the animation and create an animation montage. I'm gonna keep the default name, that's fine. And we don't really need to open it up because in this case we don't need to change anything. But normally you would want to have a look at the slot for the montage, and you might want to change the name. But in this case we're going to use the default slot. So we're not going to do anything in here, and we're simply going to create 3 animations, montages from the animation sequences. So again, right click, create animation montage, and do the 181 well. And that's good to go. So close it, let's save everything just to make sure, and let's set everything up in the animation blueprint. Let's open up our animation blueprint and let's create a function to play the turning montage. So let's create a new function over here on the left side, and I'm gonna call it play turn montage. And let's give it one input, and that's the yaw offset. That's the float that we already have in the animation blueprint. And then we also need 2 local variables, so let's create those. Well, the local yaw offset, and that's a float. And then the second one is the local turn montage to play, and that's an animation montage. So we have those set up. So a local variable simply means that it only exists inside this function and you cannot use it anywhere else. So first of all, I'm going to set the local yaw offset, and the only reason I'm doing this is to prevent we get 100 of lines drawn from this input node over here. So let me disable the debug, that's really annoying. Now I'm gonna get a branch in here and I'm gonna check the absolute value of the local yaw offset. So first I'm gonna make it absolute. So let's drag it in here and look for ABS. So all this does is turn a negative number into a positive one. So if it's minus 50, then it's going to return 50. And if it's already 50, nothing's going to happen. So I want to check if this absolute value is smaller than 60 or not. And plug it into our branch. And if this is true, then we want to return. So get a return node, then we're not going to do anything. And if it's false, then we need to make sure that we are playing the correct animation. So let's grab the 3 nodes from here again and copy them over here. So this time we're going to check if the absolute value is greater than or equal to 135. And if that's the case, we're going to play our turning right animation for the 180s. So let's plug this in here. And then we're going to get our local turn montage to play. Plug this into the true pin. And we want to assign our turning montage. So if we simply search for turn in the character folder, then we should be able to find the montages that we created and simply plug them in here. So over here we can check the absolute value again because we only have the turn right 180 montage, so that's fine, that's good to go. And for the second one we're going to check normal value, so copy it without the absolute node this time, and we're going to check if it's greater than or equal to 60. And if that's the case, we need to play our turn right 90 degrees animation or montage. So we're going to grab the setter again and make sure that we assign a turn right 90. So animation montage, this one. And the last check we need to do is check if it's smaller than or equal to minus 60. So let's get rid of this one. Smaller than or equal to minus 60. So you could play around with these values a little bit to decide when the turning animation kicks in. That's up to you to smooth things out. I think these values work pretty good. So if this is true, then we're going to play the turn left 90 montage. So let's select it and click the little arrow sign. So if the last pin returns false over here, then we can also simply return. We're not going to do anything. And if this is true, we're going to set a boolean. So let's create a new variable, and this is called isPlayingTurnMontage. And turn it into boolean. So we want to set this to true and connect all 3 of the setters. And then we're going to start playing the montage. So look for the node montage play. And grab this one, and that should have the animation instance as a target, so you don't need to target the mesh or the character, you can simply plug it in the animation blueprint. For the montage to play, we're going to use our local variable, so that's the turn montage play. We're going to disable stop all montages, so make sure you set that to false, and you could change the return type value to the duration if you decide to change the play rate over here. That will make sure that the return value is still correct. So with this setup, we're going to go back into the event graph and create a little custom event. So come on, thank you. So custom event, and that's going to be reset turn montage. And in here we're going to grab a delay, connect it up, and then simply set the boolean back to false again. And for the delay, we want to drag the variable onto the node, so it creates a variable for us, and we can simply call it over here. So reset turning montage, and plug in the length of the montage. So when the montage is done playing, it will set this back to false and enable us to play a new montage. And this, we're going to plug it into the turn node, and that should pretty much do it for the function to play this. So now we can go back to the event graph, and over here in the blueprint update animation at the end, we're going to add a branch. And first of all, we want to make sure that we are actually not moving. So I'm going to drag in the speed and make sure that it's 0, equal to 0. And we're also going to grab our play turn montage boolean and get a not bool. And then we can plug these into end node. So if we are standing still and not already playing a turning montage, then we want to call our play turn montage function. And that will decide if we play a montage or not, as long as we drop the yaw on top of the here. So that should work. Now the only thing we need to do is go into animation graph, and over here we have the blend space for the movement. I'm going to grab a little bit of room and search for the slot node and plug this in over here. And this will make sure that the montage actually plays. So as I mentioned, when we created them, we have the slot names over here, and you want to make sure that the default slot name over here matches up to the name or where this node is set to, and you can change the name here. So we're going to use the default slot, so this should work fine, and we should have some kind of turning animation playing right now. So let's see what happens. And there we have it. If we turn around, the character will align itself again, and if we overdo it, then you jump 180. There he goes. But the only problem right now is that our upper body overstretches. So we're going to look at smoothing things out from now on. So let's dive into our character and let's have a look at how we can smooth things out a little bit. So over here we set the yaw offset, and that's what drives our aim offset. And if we want to make sure that we do not overstretch, then we want to clamp this float over. But there is one tiny problem, because if we're simply going to clamp that float, then if we want to play the turning animation and use that clamped value, then that will make sure that we never reach the values that we need over here. So let's create a second variable, and one of the variables is going to drive the turn animations and the other one is going to drive the aim offset. So let's simply duplicate the new yaw offset, and I'm going to call this turning animation yaw, something like that. So let's turn anim yaw, and let's duplicate it again, and that's actually the turn animation yaw. So we have the new turn animation yaw and the turn animation yaw, just like we have a new yaw offset and normal one. So you want to select the normal turn animation yaw, and again make sure that that variable is replicated, because that's the one that actually drives the animation blueprint, and the other one we're only using that locally. Now over here we have the delta rotator from the camera, so let's disconnect this yaw over here, and we're going to get an angle clamp. So clamp for angle over here, and I'm going to set this from -60 to 60. And plug this into my new yaw offset, and that will drive my aim offset. So this will make sure that this will not overstretch the upper body. And now I want to grab a setter for my new turn animation yaw, and I'm going to plug it in right before here. And for this I'm simply going to use the unclamped value and plug it in like so. So this will drive the turn animation function that we created. Now we need to make sure that we set them, and we can do it in the same way as we did yaw offset. So for the server we can simply drag in the turn animation yaw and set it to new turn animation yaw and connect it up. And we can copy and paste the node for the client as well. Oh, one time enough. And then we also want to make sure that we add that to the server function over here, so it does get replicated if a client sets it. So let's simply drag in a setter over here as well, and drag it onto the event node, and then hook in the variable over here as well. So over here you want to grab the new turn animation yaw for the getters, and for the setters you want the replicated variables. So with that set up, we need to go back into our animation blueprint, and let's go to the event graph. So over here right now we have the yaw plugged into the turn animation montage, and we want to get rid of that and simply drag off the character and get our turn animation yaw. So get the replicated variable and not the new turn animation yaw. So if we use this for the function for the montages and the other one for the AimOffset, it should look something like this, where the character stops rotating at 60 degrees, and if we overdo it, then he will simply face the camera and jump 180 degrees to line himself up again. So we have that pretty much set up. And now all we really need to do is make sure that everything works again when we are moving. So let's have a look at how we're going to do that. So back in our character in the event tick, we're going to make sure that everything works again when we are moving. So let's change things up a little bit first. So I'm going to create a little bit of room here. So first of all, if we are locally controlled, we are going to set our new yaw offset. So I'm going to disconnect a few pins. And first I'm going to set the new yaw offset on the true pin over here. And let's drag this up here. Then I want to add a new branch in here, and I want to check if I'm moving or not. So I'm going to get my velocity, right click, get velocity, and drag off the velocity, and we're going to get our vector length for the X and the Y axis. So we're going to ignore the vertical movement, and for this we're going to check if this is greater than 0 and plug it in branch over here. So if this is true, then we are not moving, and we also want to set our turn animation and then continue like we did before. So we can simply plug it into the switch has authority and leave this the way it was. Now let's create a little room over here. So if we are moving, then first of all we want to set the yaw offset like we did over here as well. So let's grab the switch has authority, let's paste it over here, and let's grab the yaw offset function with the setters. So we do not really care about the turn animation yaw because we are moving. So for the remote we can plug in the server set yaw offset and then set it locally as well. And for the authority pin we can connect them up directly. So for the yaw offset, make sure that we also plug in the setter over here, and you can leave the turn animation yaw empty, that doesn't matter. So we can connect this up to the true pin. And now we want to make sure that we enable our desired controller rotation again if we are moving. So that's a default variable on the character movement component. If you select it over here and you're going to scroll down a little bit, we're going to use the controller desired rotation to make sure that the character smoothly rotates towards the controller rotation again, and it's not just going to snap into place. So what we need to do for this is simply drag in our character movement component, and we're going to check if the value is set first or not. So we're going to get use controller desired rotation, and we're going to grab another branch in here. So if this is already true, then we're going to sorry, if this is false, we're going to set it to true. So we can drag off the character movement component again and set use controller desired rotation, and then we're going to set it to true if it's false. So plug it into the false pin, and this is the branch for the server. So if we are the client, we need to make sure that we replicate this to the server, and then the server can set it. Otherwise it won't work. So first we can get a branch for the client as well, but then we need a replicated event again. So let's right click and create a custom event and call this something like a server set desired rotation. So server set desired rotation, and over here we simply can grab the character movement component with setter and plug it in event graph, event node, sorry. And for the event itself, we need to make sure that we set it to replicate to run on the server again. And then the client can call this event. So that's grab the false pin over here and call the server set desired rotation. Make sure we set it to true. And then for the client, I'm gonna set it locally as well. So grab another setter and make sure you connect up the target like so. And with that done, we need to do the same thing in reverse if we are standing still. So we can simply copy and paste all of this stuff to the other branch and connect them up. And then we need to make sure that we move over the pins to the true side and that we set it back to false, like so. And now this will make sure that the upper and lower body will align again if we start moving. So as you can see, that's working. Now because we are using the montages with root motion, when an animation is playing you cannot move. So if I start playing the animation and then press the move key, it will finish the animation first and then start moving. That's because we are using root motion, so this will prevent the sliding of the foots and things like that. So I think we have a pretty nice and decent setup, looking at how easy the event graph look actually. So if you're going to look at the Lyra starter game, then it's way more advanced and it's not as easy to wrap your head around. And if you look at the things we did right now, those are really pretty basic things, and I think we have a pretty smooth setup over here. So there is one thing you can play around with, and that's for the character movement over here. So you have the rotation rate, and if you lower this number, then that will smoothen out the transition from standing still to movement. So let me lower it even more to make sure that you can see what's happening. So if I'm going to stand right now and I'm going to turn, so the upper and lower body have offset. If I start moving, then you can see now it actually smoothens out the rotation of the lower body. But the downside is if I rotate while moving, then it will also make a really big arc. So you can play around with the rotation rate setting. As you can see right now, the lower body rotates way too slow for me to actually turn. So you can play around with that setting and maybe even set it dynamically depending on your speed or things like that. So there is some room for smoothing out, definitely, but I think we have a pretty solid base standing. So thanks for watching everybody. I hope you enjoyed the video and I hope everything made a little bit of sense. If you'd like, you can join the GameDev Raw Discord and talk about game dev stuff, or if you want to ask questions about videos or things like that, you're welcome to join. Thanks for watching again. Please leave a like and I'll talk to you later. Bye bye.